You've written me now, and that I'm going to jump on this. And someone sent me the link. I know a couple of you informed me of Josh's video, and a couple of you told me that I should go to the Miami Herald and look at their article. It's behind a paywall, and I'm not giving them any money. So that's that. But Josh shared the data here, or I don't know if it's the same data, but we're going to work with Josh's content. His shared content, and we'll also go to, let's just jump to the chase here. If you guys recall this, my bias is out. I've always said it looks like the butterfly deck failure, right? The butterfly. This deflection puts us at the butterfly area here. The interesting part is back here. I think this is maybe M or something. That's that dip I talked about that's in the deck. It did not show like that in the survey. It's a very small minor section there. This is also roughly what stays behind it after the failure. So isn't that interesting? How's that? Back here for noteworthiness, it appears in some photographs as just regular concrete. It appears it's like a stamped concrete with a barrier here. I've done a few videos I have not posted, and I was using some of this content. This is off the balcony, and if you look right here, you'll see that this is a control joint probably here and here that they put right there by the mouse, where they put in line with that. It actually aligns with the box, roughly where their crack are going to identify themselves. Over here, the cracks were identified coming off of here, right here, and then so we got coming off of this guy right here, the crack, and it's going back to the column. The interesting, I did notice that this was there in this imagery, but the problem is I started seeing a lot of artifacts. Like look at the split here with the can. If you follow it, it just happens to be right there where this imagery is going to go south, and then we see the duplication of the railing is not true. See how this railing comes down and it sort of blends in here? It's because of the software they use. I actually looked into buying this 3D camera, but they have a yearly subscription fee. Yeah. And I thought better of it at that point. This is the angle here. You see how it's not lining up? So all is in the car right here, not lining up. So don't get excited about that when you see it in that image. This one I titled it planter box, and I'm referencing back here. And that's the planter box that stays behind right there after the failure. I think planter box on deck was not part of the collapse, right? Okay, and then once again here is imagery of it. It's really good stuff. Let's come over to, this is the testing they're going to do. I've got many pages of it. I'm not going to bore you with it. It's an interesting, the testing seems pretty solid. Drainage plus tributary failure. As-built reveals good drainage. So where Josh is talking about drainage over here, the as-built, meaning the survey they had, shows good drainage. It drains down to right on the side of the box, the planter box. Let's see if I can make that a little larger for you. So let's see if I can I can move that over a little bit. So right here is the point that's in the background that I'm going to bring up Josh's video there, and I won't bash him. That's his first round at it. Hopefully he's able to learn. I'm learning myself on how to be more. I want people to learn, right? And I can't want them to learn and also pound their skulls. So I have to go softly now. I tried a little more softly because people don't apparently doesn't work that way. I've been doing a lot of research on it. It says that basically when you can't learn from somebody else, you're done. You're done. When you think you're at the top of the food chain, when you can't learn from somebody else, you're done as far as being able to learn yourself. Because where can you learn from if you've already decided you can't learn from someone else? I learn from everyone. Right here. So the drainage goes this way. We talked about that, I think. And then there's a dip over here. And I did I looked outside in the driveways. These are the videos I'm not posting at this time. The palm tree. I show the palm trees there. And this is because I'm going to work my way up to it for you guys. Right here is where we're going to talk about that fracture. And there's that line again, duplicating itself over here. Here's the planter box. So part of Josh's thing is the planter box and how and the lines, and he's trying to gather something from that. Well, one, I think this planter box has a little bit of efflorescence, which he does mention in a later part of his own video. So he understands efflorescence. Maybe you should take a look at that. It looks like efflorescence to me. But nevertheless, I'm going to state that I think the box is built in 2 steps. Maybe a lower box, and then he added the upper wall to it. So you can see this box was like, this was an add-on. And perhaps this box and this box were added at the same time at that lower elevation. Remember, they had a permit for it. Palm tree. Let's stay at the palm tree. Let me see what I have here. So I was just verifying different angles of the palm tree. And there's the palm tree again for my own background data. And I have here Champlain Tower. Okay. Okay. And the palm tree, we should see the palm tree here, right about here, I think. The greenery right there. So here's my butterfly failure that I talk about, and I talk about over here also. Remember the lady, I just did a video on that, where she comes out goes to where she hears the first initial bang, I believe, per amygdala theory, and that's mid-plane here. And I've shown this reaction numerous times, how it acts as a bit of a cantilever at the span. I also talked about triangle array, and that the triangle array is off in this lady, in this big deal. Oh, there's the right there, confirmed tree existing right here. Yeah, so I confirmed the tree was existing. That was my own notes. And there's the planter box. There's the plane of failure, and this is the right here. Your effect. And I've gone over that box numerous times and explained how the other side even rotates. Let me do this. This is not what you think it is. It just presents that way. And so this would be the dipped one, the one that was. Wait a minute, I get that right. So let's keep track of that. So that's called pool decking. And let's go back to Champlain Towers. This one. No, it's further up. I'm not ready to give you beam load testing yet. Maybe it's in this one. Let's go 2 more images. 1 and 2. Here we go. So it's the third one over. 1 column, 2 column, 3 column, right there. Now let's go back to. So third column. Let's go back to. This one, and I'm working my way down to it. So this is the second one over. So it's still 3 over right there, or dip. This is. Remember, a few of you wanted me to find the reaction starting here. Well, then we would have to have a high truck over here exist. I'm talking to someone in that comment. We would have to have a high truck over here for it not to have the break here, right? Or we choose it further down. Remember, I said it's the butterfly effect, and how I even get the rotation as this goes up, it rotates that out, kicks that out, cracks the box, etc. Let's go to, I showed the railing. This even pushed the railing out, the rotation, and it sprung back down behind the wall. There's our cracked box on this side. Put them to the other side, which we'll get to with Josh's video, but remember that height right there. Well, maybe I should do it now. This is sort of proving confirmation bias of my theory that the lower box was built first, because here's the same fracture plane, thereabouts the same as right here. Josh talks about it in his video here. Let's listen to what he says, and again, I'm going to be nice. Here we go.
That 99.9% of the time, when we see a vertical displacement across.
So I agree with his vertical displacement. It's a height elevation displacement. So he's saying it's vertical. I would say it's a horizontal. You know, this elevation and this elevation. Make it clear it's an elevation displacement. How did you get there? How did we get there from here? Do you see it bypassing, scissoring each other, causing a buckling of the materials? Well, you see some paint held on, stretchy kind of paint. It held on, it kind of buckled it right there, wrinkled it over. Interesting. So this is mapping. This tells you it goes back up to here. Now I can see behind it. So they didn't really tie the wall in. Oh, I have better imagery than that. Let's do this. I'll come back to this, but I want you to see. This is one of my images I have over my little account over here. And what I've always kept talking about was this crack. This is the crack I talk about, this fracture here. Notice it. It maps over to here, over to this angle. And then there's another one that duplicates it. It's once this clears it, it's about the crack box here, and it goes backwards. So I said that in one of my videos, I don't know if I posted it or not, I have it though. It says that perhaps when that sheet came down, this one, it caused this crack. But this one I have as not the same. Look at the ultimate failure, what it looks like, the failure state. And I'm putting the hinge point back here. Josh does not put the hinge point there. I put it, looking at this image, Josh is going to talk about it, but I'm going to tell you that, let it play.
An open crack joint. It's not so much because this side has gone up, but it is much more likely that this side has gone down.
It would be an elevation change is what we're looking for, and you would look for materials out on the deck that are bypassing, crushing each other, buckling each other out there, because you get nothing for free. Because you can't measure it doesn't mean it's not true. On the underside of this pool deck, you would see spalling, opening. And now we know this has a history of it. And remember, I was doing a mapping of that when I got shadow banned, and I was like, you know what, I'm pissed off. Maybe it's over here some more imagery for you when we get into my images again. We'll go through them. So this is going to probably be 50 minute video, so bear with it. And that would indicate the sagging of the deck. How about that for sagging? And that goes straight down the middle. If you remember, I did a video saying when they did that repair, the build when they did it in the 80s, they just had that weird drawing that caused for the caulking of the underside, and I believe it's the underside, and that would identify the cracks, the mapping of it. All right, so Josh states that their engineer, they had come back out, and this was only, this is reported to happen on June 8th, just 3 weeks before the incident, that they said it was growth that elevated this. Well, you would have a 2-year timeline between the last time they photographed it and not, but let's do this. I want to let them play, and then I'll narrate.
The left side has gone down. So looking at this photo, it looks more to me like this side has gone down, and this has essentially stayed put.
This side is stayed.
And when this side goes down, it took with it some of this area down here. So I'll clean up some of these arrows. So we're talking about this lower course of block. You can actually see there's a vertical displacement in the block here.
So he's talking about the elevation change here as he references vertical displacement. See it? All right, so let's listen to it. He's now post hoc ad hoc. He's getting a little focused on he's missing the forest for the trees. So Josh, I'm sorry. It's not an attack on Josh. I need to adjust my attitude. It's not meant to be an attack. Forest for the trees. He's got a lot of data right here. Now, you know how I do it. I'll pause and I'll let you look at it so you guys can beat me to it before I give it to you.
Okay. And I've looked back at the photos. This isn't just missing mortar. There's actually a vertical displacement here. All right.
So let's jump to the chase a little bit. If this was done years ago, let's call it, and this water is coming into this box, which it would be, and efflorescence, water would penetrate, come out here, you would think. Maybe not. Maybe the drain is the least path of resistance or the bottom of this box. So we don't see any water staining out here. All right, but I'm giving you a lot of hints. Go wait for it.
And so what it looks to me like is that this side is going down. It's taking this joint. Notice this joint isn't cracked here at the bottom, okay, of this corner. And so it's essentially, it is taking this block down with it. And this, again, is staying, it's wanting to stay put, but it's sort of torn between the two. It's not sure if it wants to go down or if it wants to kind of stay put. So it's kind of following down a little bit as it goes down.
All right, so let me help Josh out. What's going on is a rotation. The deck is sagging, and the sagging side includes this part of the deck. This elevation change creates that buckling, and you lose the mortar joint here. Take note of the left side of the planter box. See, that would be the lower box, and then they added this top box on top, this other material on top. And yeah, they did a terrible job of blending. They have a history of that. If you look at the outside wall, the same thing, the caps. They have a terrible job of blending. But it maps the different material. Perhaps over here, perhaps it's something as simple as the guy said, look, I'm parging my new block to blend into there, and when you paint it, it's your issue. So it may look like you're looking at a bad parge job, which it might be, but the paint then covered it over and made this consistent. Remember, I don't give anything for free, nothing for free. The stretchy paint is able to bridge that. It looks like no buckling or anything on this side. So I put the hinge point further back here, probably somewhere about here. Keep in mind, I giveth and I taketh. Let's take it for now. Let's go. So there's that, what I showed, the fracture on this. Remember, the box is over there, the one that's fractured by this trash can. This side shows my confirmation bias. This is the inside, backside of the planter box, which also has a waterproofing membrane-ish on it. The triangle array. So I go over triangle array in these images, and I point them out, saying these are the areas that behave. It's a great span. So I posted this one. This is on February 10th. I screenshot and did this one. Oh, there it is right there. Thursday, February 10th at 4 a.m. And then this is the underside where I talk about the tributary failure zone. And this one I posted 10th of February, so same time. And this is what I'm talking about, right down the middle here, the tributary area failure zone. And that's where I come at. Look at the fracture line that I run here. And I make, this is the mapping of the ceiling. I show these mapping. And the lines all come to cross each other in the tributary zone when I map these lines out. I did more of them. And we have the sagging deck right here. We have and we have our loading of the vehicles, which I talk about. So as we look at the planter box, I talked about the triangle array, and I said this is so far off. Remember, I talked about the degrees of it being off, and I said it doesn't meet ACI standards per the code back then, even nor today. It doesn't meet it. And I said this one's way out of bounds. And lo and behold, this is right where we're pointing to where the failure starts. And let's see. Okay, so I stated location indicates where planter box and car loading at K. Okay, so this is the one I pointed out at. This is some of my mapping I did, and this was done on 15th February 2022. And this is the one I'm picking on. Lo and behold, this is the fracture. And remember, I didn't have access to these images not until just now. So this could be confirmation bias, even though I'm right on top of this. I'm right where it's indicating at. I have, history of it. But I specifically pointed at this one. I talked about its huge triangle, how much it's out of bounds. This one right here. That it's so out of bounds that it's overloading this area between it. Now this is the planter box on this one. And this is our correction. So that's one back. That's K. So it's one back. Correction. This is the back of our planter box. Oh, this is the one here. I'm sorry. So it's this little lady here, the 6 foot off. There it is. 6 foot off, and then this way. I did it two different ways. So here's our K line. All right, let's find it. All right, so now we look at this hinge point here. So here's a hinge point. Remember, it's in plane with this one going all the way over. What this indicates for me, reminds me that I was doing something acting like a cantilever effect of the reinforcement. Oh, showing that there's plenty of reinforcement, two-directional, and a lot of reinforcement is in there. Going back at that. Okay, I won't go into that. Oh, and I did this one back in 15th February 2022, and it drove me crazy trying to locate this location, and it was just data I'm just stacking up, and I'm looking at the zippering effect and unzippering effect of the reinforcement. Now let's go down to the elevation changes. Right, okay, so this one is the, I say here, two-way slab yet. I did not observe the two-directional rebar, so it's a little bit higher up, I'm thinking. I'm just sharing my notes for myself. This is my butterfly that I talk about right here. And that's right at the planter box, and right here is that hinge point. See how the box can bridge? I talked about that a long time ago, how the box acts as a strong back. And here's a little compressive fracture up. There's an engineer on here I'm talking to now that, if you recall, talking to this one engineer. She knows who I'm talking to. Remember we talked about that? Well, this is the other side of that box now. And let's move on to... I'll get back to that. I said it would take a while, so let me zip through these real quick. It's not coming up fast enough. Yeah, shapes. Here's my triangle array again. I'm trying to look at the loading of it and working it from there. And I just keep getting this deflection. Back then. Oh, the floor. I'm showing in this one that the floor is, so this would be Charles. So here's your floor. You asked me about the floor. Is it kind of supporting it is? You don't see it punching around here, but you see a fracture in the center span of this. And to me, indicating a sound that if the hammer run a chain across it, it might, if it got some, as I said to you, subsidence of the soil below. And Charles is a geotechnical guy, so it's okay. Here's ACI 13. I don't need to show you that. All right, so datum. Why do I have datum on here? Oh, the datum's found. The datum's over here. For anybody looking for it, it's here. A few engineers told me they couldn't find it. I couldn't find it. It's right here. Oh, I found it. There it is right here. So that one says datum. So do we have to go down here? No. We don't have to do that. I guess I will in just for a second. Where it says it's not the garage. This shows the concrete on the floor of the garage indicated failure of the lobby level slab. This was before the building collapsed. This video is unlikely to be the Champlain Towers. Unlikely. Okay, so that was foul. Okay, so going back to this one, I wanted to show you the, you know what, I probably got it over there hiding out. We'll do that. We'll bail on that. I'll come back to this. So our reaction, our dipping is here, and let's go to here. And so there's our bit of a cantilever. See how the plane is kind of flat there? In plane here. So when this went down, see how the tile present as being kind of flat? And this ejected the top part of this off, and it rolled over here. It was right on top of the box. But the cantilever effect, so this same thing you see here, I believe has happened at the wall to explain that fracture there. And now we're on top of a car, perhaps. It's another option. Now let's go to the, let me back out of this. and I'll escape it. So I'm going to go to the top here. Piano box, porch of condo, right? We got that one. The cracks when we were hunting that deck. Let me push it up. Let me push up here a little bit. Okay, here's the triangle array I talk about right here. This one right here. I said 50 degrees. Note, this is the direction of the cracked deck. This is the direction of the cracked deck. I guess I believe in this direction here is what I'm saying, because I'm reading it again, but I have an arrow. Oh yeah, all the offsets. There's 2.5 degrees, there's 10 degrees. Now this can, I call it 50, but I can measure it differently and get this to be, from here is 50 degrees. Oh no, it's greater. Yeah, from here it's, when I start the triangle right from here, which I should start from here, it comes to, it still exceeds it. Oh, from back here it's 14.6. Is that what I calculated? And on this one, it's like, okay, this is a 2 degree offset from this one to this one to 8 inches. I think I would have this one too, also. Although there's that one in the background that's 5.8 degrees offset. That one is tolerable. This one is the largest strain though. And remember, this is off, then this tributary area, what does it look like? And it's off also, because now this would be the inverse of this tributary area to here. Now, I think you have to take all the panels in consideration up to the control joints, not just one panel, if you will. I think all of this is an acting member. I put, these are vehicles, 1, 2, 3, and 4. And then this one's 13 degrees, that's 2 degrees, that's 20 degrees. That's huge. It's got a little shift to it. And then here's our center line. Note, the steel does not run in the angle of offset, resulting in torque loading. All right, so this is, when I do this, this is the major one here. This is the one I really picked on. And I picked on this when, what date is this? Screenshot 2022. Okay. I have my mouse over it. So that was February 8th. February 8th. Yeah, February 8th is when I did this one. And it's 7:08 the PM. So this is when I did that one. And that's that. This is the one that we're looking at, the planter box right here. Now let's race down. So we got that one. You got that one on your hat. Let's race down and find yeah, so there's that one dipping in. It's gonna load. I gotta wait for it. I know you guys can pause the screen and look at them. If you really want access to them, just let me know. I'll give you access. Well, let me tell you, I'll give Josh access, because I'm using his data there, his thing there, so he can have access if he wants to look at these files. So I'm here at this. Let's just identifying marks. I won't read into that more than I should. The one up top did it more. Okay, so here's the box again. And we did a whole video on this, how you got this box to flip over. And when we look at it, it's blocked. Josh believes, see the block behind this? Josh believes this to be a solid pour beam up top in his video. You see the core? That's what I was trying to get to. See the core at the top? And then it's got a little cap on it. It's parged together and it just held together good. Maybe they put some wire reinforcement at the top. Like right here, this is not there. I'm sorry, my mouse, stick with me, finger. Like right here is also hollow block. They're hollow block. See them? So it's not solid poured. And this is that direction, I would argue. Remember the ears, I argue, the rabbit ears is what I call them, the shear head reinforcement. Tells you our direction, which puts it, back behind us a bit with that rotation. let's go. And this was done on. Oh, it doesn't matter. I didn't beat up more. I'm trying to scroll up. I'm not going to keep going in this one. You know, this has got a lot of data in it, and it will. I can probably find it for another video for you. Let's just do this one. The one with identify. Oh, this is me trying to find that rubble. All right, so this is actually in Colorado. I was trying to duplicate the rubble that we see in the wall as impact. And this is the closest I came with it. This was a car that did this impact to this reinforced concrete wall system. And it stoned that thing. Look, it turned it to stone. The car went over there, a truck went over there, and doing so, it created these stones. And look at them, how they're right on the edge also. Remember the wall system with what appears to be the stones from outside. And I talked to an engineer down there, and he said that's the stone they also have on the outside. It's a limestone, I think he said it was. All right, we talked about the cracks. It's this area here I'm talking about. I'm sorry, right there. Don't chase that rabbit. There's nothing there. And I said she's going to have great info for us because she identifies the this is the one. This identifies the reaction coming out of the shower, the ceiling, spraying her with spalling materials. All right, so again, this is the one that I picked on, and I did a couple of videos on that. Let's see if they're now ready. Let's hear Josh first. So there's our rotation.
So the question is, why would a planter box wall be sinking? What is it sinking into? We have to understand that these planter box walls are sitting directly on the structural deck. It's also important to note that
this is that's the same height as over here, same as this one, and there's a displacement that's forward and backwards, presented as forward and backwards. I don't see the water, but I know I see this down here, and I would say it's probably dipping somewhere about here. And that would be biased now because I have hindsight, but this is for sure, hindsight and confirmation bias, because I had it back without having the other image. I would have it reacting right about there, but in reality, it leaned over a little bit into me more. And as you can see, the box is leaning away from this box, not towards it. So that's not towards my vehicles, but that's away. So that puts it leaning out here now. Our stresses are out here. Our failure is out here. And now that would put a stress on the column head here because it's got to displace. To do that, it's going to probably be some spalling on that side, or I'm guessing spalling right about here. That will put the stress now moving off of this head, the shear head. It now puts it out here into the off of the probably critical shear area, probably outside that zone, and maybe very close to it out here. And now this next pickup point of taking the load is back here, and the other one is behind me to the left. The next one is behind me is straight behind here, and back to the left a little bit, right back here. So one was over there behind me, and the one's over here, way over there. One's way over there, but this one here should be way up here per ACI, but it's not up there. It's way back here, and so that's where I'm saying that the problem happens. Now look at this video I titled back in 9 months ago. I'm sorry, I should have let you see. This is 9 months ago. I put it here. I said Champlain Towers building collapse. Why was the deck dipping pre-collapse? Tributary failure discussed. And 49,000 views before it got ghosted. But there's that dip there.
Let's go back at it again.
And I look at it. Let me see. You guys can have it. You can see the title of the video now.
Tile guy be responsible for the.
I said, could it be the tile guy? Could he have made this profile towards a drain or not? You know, that's what I stated, but I said why, and by chance, it's in the area of failure. Now let's go to, I say by chance. Now I say the butterfly failure. So let's go to, I'm looking at the content. So I want to look at concrete cracks and shear, right? I want to look at the whoa. So I can't even find my own videos, guys. A lot of them have been ghosted from me. Like this one just says deck failure, and I'm trying to find the one that that might show. FIU. That might get us over there. There's the butterfly, and I said, remember this one? I said he states the exact load path failure of cars first, then deck area part A. And this is where he states my butterfly, talking about my butterfly failure. And you can find this one then. I think it's called right here, Champlain Towers collapse. Witness states my exact load path failure of cars first, then deck area. Oh, that's what I was trying to find for you. My image showing that. Witness feet from collapsed decked vehicle details, reveals details. And I'm really heavy into that area over there, as you guys may or may not know. So I really beat this one up. If you want to find this video, it's called Champlain Towers. Nope, wrong one. Yeah, it was that one. Witness feet from collapsed deck and vehicles, more details revealed. That was 9 months ago. So it would be I know what I'm looking for now. So it would be this one, and it would be they got rid of my butterfly deck failure because it didn't have a video. You guys know I'm talking about butterfly. Now all of a sudden it seems like I didn't make a single video called butterfly. That's weird, isn't it? Well, it's just butter. Maybe I spelled it wrong. Often I do. How about 1T, butterfly like this. 2 T's. That's weird, isn't it? So, why does that come up with butterfly there on this one? The B? Yeah, so that's weird, isn't it? Because you guys know I was going crazy over that butterfly deck failure for some time, and now all of a sudden I can't find a video called butterfly deck failure. Maybe you guys can find it. That's quite strange. So how about deck deflection? That's that one. I'm trying to show you how the reactions work on those. I'm showing that this is the outside area of the column, and the failure is really out here, not enclosed. And this one I'm showing that the reinforcement acts like a cantilever, pushes it further out, and then we get our middle failure here, not close to where it was. It says proof deck was attached to columns of building and not freestanding. Okay. I'll show you how that works. You can pause and get the titles if you want. There's the 1979 code plans do allow for architect to inspect his own work. They do allow, so no foul there. There's the one with the arrow, the one there, 0.2 with the arrows. There's a model of the FIU bridge I did. It's a real scaled model, so about maybe 3/8 of an inch. That's me standing on the model saying it acted like a truss system. It was pretty impressive. And yet he didn't design it as a truss system. It was just all supposed to be compressive. But it had some redundancy in it, whether they like it or not. That's me trying one of the nodal areas only. So let's go out of that now. Some post-tension stuff. Near has critical information about the collapse, when she talks about it ejecting the materials towards her. It shows the touches. I'm showing you how bottom steel works. And that one. There are the cameras that they were not revealing to us. There's the deflection with Georgie helping out with that one. Champlain Towers revalve rust acceptable. For everybody who got upset about rust, it's acceptable. The Cassandra was renting, and so that's weird. Maybe it's on my other channel, or maybe it's been ghosted off of here by YouTube, because now I can't find my butterfly. How about Witness? He's there, and I think I stated with him right here.
First off, I could not find his 911 call where he states he make calls 911.
I did find it. I did found
I don't like the convenience of his story matching my story.
Matching my story.
I just don't like the I like to think of myself as badass and everything else, but his story aligns perfectly with my story, and I don't. Usually I have some defect in my story that I'm like, yeah, that is.
So look, that was July 16th I posted this, where I'm talking about my butterfly thing, and he mentions it.
And match it, add it in. My story of the cars collapsing first, then moving over. This video is posted July 14th. Here we go.
Okay, so he talks about the butterfly failure there. You guys can still find that. I think you can find it. I know some of these look like they're public videos, but people are telling me they're private. I know it's not me. Look, I don't have it marked as private, and some of them you can't get to. So let's finish off with Josh. Let's see what he says there. So
this area in general is the area where...
Well, I actually we don't need his narrative. You guys can believe his narrative or believe mine. I don't frankly care.
And falling down here, and that's what's causing this vertical displacement. That doesn't fit because nobody's ever seen it. I mean, most engineers will go their entire career and never see a building collapse or even partially collapse. Okay?
So he's saying he wouldn't see it. What I'm saying it's exactly what he's saying it's not. Listen.
My fourth point about root damage. In order to conclude that this is root damage, you have to cut back these plants.
Let's let him go.
And you have to dig down in the planter bed, and you have to actually be able to observe what's going on here. I just drew like a really funny face. Anyway, you have to kind of be able to observe what's going on in that.
So look, this shows craftsmanship. You see the craftsmanship here? It's just nasty. And the wall showed it was nasty over there. There was no craftsmanship there. You can see the variations in colors.
Cavity. You have to actually physically see roots. You can't just conclude there are roots. So I suspect that without any excavation being done,
we gotta wait about 20 seconds. Here we go.
That it didn't fit within the paradigm, the mindset of the person.
He's saying he doesn't agree with the engineer that stated it was roots that caused this fracturing. I don't agree it's roots that caused the fracturing. Frankly, this one's the one that concerns me more so than this one, because there's no cracks underneath of this. There's no fracture at the base of it. So this would tell us what? That there's no deflection taking place at this point on this deck. This one doesn't appear to be that type of spalling and anything else, and they didn't take a photograph of it. So this is a positive thing to see this from here to here, this solid beam, if you will, made a block, which would identify as cracking a lot more than a solid beam, just so you know. And so now it says, oh, we're over here. Exactly where Josh is going to say it's not is exactly what I'm saying it is.
Person who was out there to say, well, gee, maybe the slab is sinking and falling down here, and that's what's causing this vertical displacement. That doesn't fit because nobody's ever seen that. I mean, most engineers will go their entire career and never see a building.
So let me help him out, because I figure Josh is young. So let's go with let's help him out with that. Remember I did a video on that already? Yeah, that's ugly. And so let's go back to he used the same video I used after me, so I want to make that clear that I sort of like it matters that way. But the punch shear one I'm going to show, and yes, I said punch shear. Don't get upset. Don't get all crybaby on me. Okay, so it's the one with the column through it, and come on, sweetie, where are you? I guess I got to go down further. Maybe it's up higher because of the content. This one. So this would be the dipping of the deck out here, and this dipping of the deck, and you can see it dipping here stressed, and this actually shows the critical shear area and the critical shear zone. That's all intact. Look how square it is. The rebar being in that direction, and the other direction, cross direction also, meeting at 90 degrees. This is like a perfect mapping of that, showing what a critical, and here's a piece of it on the ground, what a critical shear area looks like intact. This is a three-sided critical shear area. Two-sided, three-sided, yeah, because then out here is just airball. I think it's just space. Out here is surrounded. So the deck, and here's the deck down the ground, it deflected between these two areas and did that. Or you think it was just dead load and it just bypassed each other, just magically just did that without even bending this rebar doing that. That's a ridiculous statement on my part to say that. I'm just playing facetiously. There's the asphalt on top of it. The decking took place, the deflection took place back here, I believe, and you see the more crumbled material. It went down. It had the most stress on it and deflection, and it just balled a lot of this material off. At that point, this was two-sided or three-sided. It just hinged, breaking free. It just hinged, and that's why we have a huge section here. It hinged forward and then just pulled away from the back edge there. Up here, it's elevated at the top above. This is the pad that was above, and then just swung down and broke free. That's basically what's going on there. So Josh, to educate you, that's what you're looking at here, the deflection there. Now I'm going to do this with some paper for you guys, but I don't want you to get confused. I'm going to grab like 50 ream some paper, and I'm going to push down in the middle of it. And you know what's going to happen if I put it there. The top part of the reams will actually push out further than the lower parts of the reams. And so I want you to think of that as internal force, your FIE, your elemental modeling. And I'll explain to you a little more differently because it matters. The deflection, the stresses matter. They matter. So, and for the profile I'm trying to describe. But this acts as an indicator for us to show us that, oh, wait a minute, it is over here. The deflection is actually what Josh is saying. It's not. The deflection is here. I am positive on that one. On that one there. So, and this is my indicator of that. Might be more out here. Biasly, I'd like to say it was near the car area, even though I already pointed this out in the other one, the stresses. And I also put it between here, but I said I have three points. It would be one at the wall, one here, and then one bay over. It's that long bay, but the butterfly is my bias to that.
Building collapse or even partially.
And then I've supported it with my triangle array theory that is used, and I supported it with that, which is the bias support, but nevertheless, it appears to be nailing these photographs.
Okay, so it's not in most engineers' paradigms to think in these terms. So when you come out here and you look at this and you see this vertical displacement at the...
All right, so let's just fast forward. He's already made up his mind. He's trying to prove it to himself. Let's go with this one. So I already had these drawings up too, and this is where that dip would be here to here. Now remember, I showed the triangle array how things are off. This is off to... Where's the other column here? It's not identified. These are the drains. These are the drains. These aren't the columns. Okay. And for Josh's purposes, if he looks at the survey of the report, you'll see that it's only a dip here. There's a drain here, and on a survey elevation, sites all point towards the drains. Well and done, except for we do have a photograph showing water stains and also rain over here, even the puddles. But we don't know how much. You can't tell the depth of it. With that said, it's still the top layer. We don't know what's going on sub-layer because it didn't take a surface we're not go underneath the garage. At least we don't have access to it, and take a survey of the underside of the pad to determine if deflection was going on. They just went from the top, and from the top it was looking pretty good, except for this one showing up weeks later, and they sent out his amateur guy to do it, and he just gave it a pass with the root. At least that's what Josh says. They said. I didn't read your article with the root deal. Okay, so these are the columns now. So this is the triangle array thing from here to here. See that offset? And that's that the butterfly right down the middle here, and it's this huge offset. And I show that in these guys over here of my offsets. Where are you, baby? Wrong direction, right direction. So you see, I try to debunk myself or find another source of the stone. See that stone aggregate again? After a truck went over it, it pulverized it, and it made that. But we also had a stone there. But I wanted to see if I could duplicate it through a compression, crushing failure, abrupt and compounding forces, and I don't think I can. I think it is just the stone. So here's my path. I have I think I loaded the video up. I showed the line through here, or I'd have to track it down. But this is the triangle array. See how this is all cocky and wonky? This one's wonky, that one's wonky, this one's wonky. This is where it all goes south. But everything over here is pretty much balanced. From the back wall to here, back wall to there, save it has a planter box on it. But these are all balanced. And from here over, it just goes wonky. It goes south, 6-inch offsets, 12-inch offsets, 2-inch offsets, 9 foot 6 inches offset from there to here. 9 foot 6 inches. And I have that at 20 degree when I do the math. This is 13. I only have that as 2, but I don't know if I'm going to even try about that. But this one is the one that I decided was the most stressed, because this is where the column should be, right about here, where the 6 foot is. And then the BMA would have saved this, as I talked about it. If they would have put the BMA in there, we wouldn't have had that stress. And I do state that with the BMA. If you remember that one, I think that one's pretty clear that I state the BMA. And go.
The drains that more.
Let's move this one up. Let's go to this one for the last one for too much. So again, this is the terrible skill set of the parser. You can see it appears to be 2 different colors. Perhaps it's just paint, but look at this. I mean, it's kind of smooth. That's the block standing forward. I mean, I don't know who did this. Standing proud towards us. There's no cracks indicated, though, besides right about here, which just means it could be the mortar dried too quick. But what's interesting is, they've been over here, though, and it's a photograph, so this may be, a little funky here, but I've got this standing strong. Remember the column is about dead center per the as-built survey. But we have separation here. Separation away. We can look into it. There's a little bit of growth in there. So this is where they took the checkpoint, the survey at. Looking at the parging, I would say, okay, they ran this up to there, and now it could be, it could be this not shrinking. I wanted to say shrinking, drying out. I don't know what, how new this was. Remember I talked about that. Were these tiles air drying, sun drying still, or were they done? But the elevation change, this is, as Josh pointed out, added later. These 3. I thought he said 2 tiles. I was looking on my cell phone earlier, and that thing's cracked up. So just looking at a cracked screen. So not now though. So these are the added tiles, I believe, though. Maybe more of them. It doesn't matter. It just shows that they could care less, their quality. Fit and finish, F&F. But this has a little bit of a dip to it, and a little dip over, kind of weird, odd. And that one definitely does its deal, right? So where's Josh at? Okay, that was this video. So yeah, back to that. That's our plane, and he thinks this is a solid top wall. And I'm saying it is not.
Force of masonry, and then a 16-inch beam on top. Okay.
Yeah, he thinks it's a 16-inch beam, and that's the same thing he said here. So just so you know, it's block, and that's why I said Josh can have access to, if he wants, I'll give him the imagery of this with showing it's a core. It's a block, and again, the best, one of the best indicators is that this is acting like an indicator showing no fractures. So we don't have any dipping here. It's here. Biasly so. It's from here back. I mean biasly so because I can't. It's kind of blurry. So you know, another photo. I reserve some percentage to say. Well, I don't see any cracking in this, but the I reserve to see if that's going to be separated. But this is definitely cocked away from the wall. That Morbido's assistant, I guess, sort of reminds me of the guy beat up on FIU Bridge, Denny Pate. And Denny Pate, I don't think he did the post-tensioning. He signed off on it. I think it was the girl engineer that did that one there. I forget her name. I did a video on her. But I think she was the post-tension lady, engineer there. And so she, you know, but you can't throw it on the underling. You got to sign off on it. So Denny Pate the bus rolls over top of him, but he did, you know, did the meeting. He ran over top of those people there, so they didn't stand up. All right, so this is a you know, a nice serious identifier. I'm going to end the video with that because this would take too long to go deeper into it. But as you can see, this, if you look, oh, that's it, triangle array. So I want to look up triangle array. So that's not going to be it. I don't know if this is going to work. I might have called it Cassandra. Yeah, I got toasted on that, didn't I? Dumb me, thinking I could look it up. And the YouTube, stupid me. That was brilliant. Okay, your channel. And then right here.
A little louder. I can't believe it. I just wasted 30 minutes of my life doing a nice edit for you.
Let's try that. How about, ooh. No. I might have called it offset. Wow. I think it might be gone. Champlain Towers, NIST evidence that conceals. Right. Reveals world economic. Wow. I can't find a lot of my stuff. Sorry, guys. It's not. It's, you know, hey, some of it's gone. You know, nothing I can do. That's the way this world is now. That's nasty. So you guys, I hope you remember the triangle array video I did, or maybe you can find it. But this is what it was dealing with when I talked. You know, you remember how many times I talked about my butterfly video? It drove me crazy talking to you guys about it. And this again is posted. When did I play with this one? Looking at the date, it says. Oh, that's too far up. Really? Okay. All types of codes and all that. Okay. The damn date. Wait, where's the date? 3 months ago. 3 months ago. All right. So, yep. So 3 months ago, I did right about 3 months ago. If you guys are gonna try to find it, I did that video. It might be on Twitter. I mean, it might be on the Rumble, or it might be on the other channel of mine. It might be on Rumble. If I can find it, I'll link it. If you guys find it, I'll put the link down below. But this is what I was picking on, this triangle array, and that gets us a butterfly. Stressing back, and over to here we have that. Yeah, right here we have the column fractured, and this is K. This is the K column. that I pointed out initially. Take care. Love you. Bye.